we have multiplication of algebraic fractions. We know that to multiply algebraic fractions, we have to use the same rule like for multiplication of fractions. So it means we have to multiply numerator times numerator and denominator times denominator. So this is equal, we have, now we will put one fraction bar, and in the numerator we will have 16 a b squared times we have 42 m squared n to 5th power, and in denominator we will have 14 m to 6th power n to 4th power times 4 a to 4th power b to 3rd power. Next step, because we have multiplication only in the numerator and in the denominator we have multiplication too, because if we don't have sign, we have like 16 times a times b to 2nd power, and the same we have in denominator, we have only multiplication, so we can check if we can reduce something. So first we check the numbers. We have 16, and we know that we can reduce only numerator with denominator. So we have 16, and in the denominator we have 14 and 4. So I will reduce 16 with 4. The greatest common factor for 16 and 4 is 4. So 4 divided by 4 is 1, and 16 divided by 4 is 4. Next we have 42 and 14. The greatest common factor for 14 and 42 is 14. But if you don't see, you can start division from the smaller number which you see. We had at the end 2 and 4. It means that these two numbers, 42 and 14, you can divide by 2. So if you see, you can reduce by 14, or if not, you can start from the smallest number, by which is divide 42 and 14. So 42 divided by 2 is 21, and 14 divided by 2 is 7. And now we have 21 and 7. 21 is divisible by 7. So 21 divided by 7 is 3, and 7 divided by 7 is 1. So now we have in the numerator 4 and 3, and in the denominator we have 1 and 1. So 4 times 3 is 12. And in the denominator we have 1 times 1 is 1. We don't have to put 1, so, but at the beginning let me put this one. And next we have to put variable in the alphabetical order. So first we have to put a, b we have to 2nd power, and next we have m square n to 5th power, and in denominator we have a to 4th power, b to 3rd power, m to 6th power, and n to 4th power. Next step, because we have the same variables in the numerator and in the denominator, it means we can reduce. But in my opinion, it's easy if you first rewrite the smallest power we will copy. So we have a and a to 4th power. Here is like invisible 1. So the smallest power we always copy, and the greatest power we will write to the power which we have in the numerator, and the rest which we need to have, because we cannot change the expression. We have to have the same value which we have at the beginning. So from first we have to copy 12, and next a to 1st power I will copy, and in denominator I will rewrite, I don't have to put this one, and I will write a to 4th power, that this is a to 1st power, times a. 4 minus 1 is 3. You see, we have the same base, property of exponents, so we add exponent. 1 plus 3 is 4. It's still the same expression we have here. I didn't change anything, but now it's easy to reduce. We have a in first power and a in first power in the numerator, and we have multiplication only, so we can reduce these two expressions. But first we will do the same with the rest of variables. We have b squared and b to third power, so the smallest is b squared, so b squared we will copy, and b to third power we will rewrite that this is b to second power times b to first power. 3 minus 2 is 1, and you see the same base, so we add exponent. So we have 2 plus 1 is 3, still the same what we have at the beginning. And next we have m to 6th power and m to second power, so the smallest is m to second power, so we have m to second power in the numerator, we copy, and the numerator we have to rewrite to the same power, so we have m to second power, and we will have m to power 6 minus 2 is 4. Now you see these two expressions you reduce. And the last expression is m to fifth power and m to fourth power. M to fourth power is the smallest, so we have to copy n to fourth power, and m to fifth power we will rewrite that this is n to fourth power times n to first power. 5 minus 4 is 1. So now the same base we have. When you add exponents, we have still n to fifth power. We didn't change anything in numerator and anything in denominator, and only rewrite. And now it's easy to reduce. A to first power we can cancel with a to first power. b squared, m squared, and n to fourth power with n to fourth power. So now we have only multiplication. So we have 12 and we have n to first power in the numerator, so we can write like 12n only, we don't need first power, and in the denominator we have a cube times b to first power, we don't have to put, and we have m to fourth power. This is my solution.